Hello and welcome again to this series of LEDIL product training videos. My name is Tero Makinen and today I'm going to take you to this fantastic topic of UV disinfection. We have just released a fantastic new optic for the UVC applications called Violet, and today we are going to look into a little bit more in detail about how the Violet works and what are the benefits of it. But before we dive into Violet, let's first look at the UVC disinfection a little bit more in general. As we know, ultraviolet light is the range of wavelengths just below the visible light range. It's divided into three different bands. We have a UVA, UVB and a UVC. And the UVC of those bands is especially the one that we are interested about here. In this case, it starts from 200 nanometers, goes all the way to 280 nanometers. And what's unique about UVC is that it's capable of killing all kinds of bacteria and viruses. And by killing these pathogens, it helps to disinfect the surfaces and prevents diseases. Very useful. Ultraviolet light is, although we cannot see it very clearly, or actually in case of UVC we cannot see it at all. Ultraviolet light still behaves just like the normal visible light. So it follows the same laws and same principles, although because it's outside the visible range, we are using radiometric units to measure them, but they behave in a similar fashion as the photometric units. So there is a similar analogy how we can actually, and we can, in some case, we can even use the lighting design software to analyze the light distribution of UV light when you're using it with the lenses. So the UVC light follows the inverse square law. So if you double the distance, the amount of UVC exposure is reduced down to the 1/4 of the original. It's also, in a way, you can measure it with using the same units. So where in the realm of photometric units we are talking about the lumens, in the case of UVC, we measure the radiant flux, and that is measured in the watts. Same unit as in your cordless electric drill or your other electric appliances. However, in this case, we are talking about UV energy. Cool. And then we have this amount of UV light measured in watts. That is directed into some specific direction. That is the radiant intensity. And that is measured in the watts per steradian. And watts per steradian is more or less the same as candelas in the photometric units. And then what is most important thing in the application is the irradiance. That's the amount of UVC light which is falling into the application that we intended to use. How this irradiance can be used for calculating the germicidal effectiveness of the UVC. We have a new term which is called dose. Dose is the amount of light falling into a surface area, watts per square meter, multiplied by the time that it affects on this area. So you can measure it either as watt seconds per square meter, and as we remember, watt seconds, they are more or less the same as a joule, so we can measure the joules per square meter, or more likely millijoules per square centimeter. Then we have some aspects where UVC is differing from the visible light. For example, it scatters in the air, and that is reducing its intensity more then the visible light is diminishing when it's traveling through the air. So don't expect UVC to go over the long distances. You're going to surprise how little UVC is actually going through the air. Traditionally, UVC has been produced by mercury lamps. Mercury lamps had a very short lifetime. Recently, the UVC LEDs have become a much more viable option because they have a longer lifetime. But not only because of the lifetime, they are also a lot better controllable light sources than the mercury lamps. So you can easily adjust and optimize the exposure. You can also use optics, such as violet, for example, with the UVC LEDs, to focus that little amount of UVC LED you get from the LED so that it falls in the area. One particular thing that we must never forget when we're dealing with the UVC is that it's highly energetic form of radiation, so it's also possible health risk to humans. By the same mechanism that allows it to kill the bacteria and viruses by breaking the DNA, it can also produce skin cancer on humans. And also it will lead into sunburns very quickly. This is absolutely important to keep in mind because, as we know, UVC is invisible to the human eye. Therefore, it's a good practice to incorporate some visible LEDs, like, for example, this blue one over here, to indicate that your UVC light source is turned on. By the way, there we have just blue LED, not UVC. Otherwise, I wouldn't be giving this speech here. And another thing that keep in mind about UVC is that very short UVC wavelengths, they produce ozone, and ozone can be considered as a health risk on higher concentrations. So UVC is a contactless and chemical-free form of disinfection. This is good because in some cases you just cannot go and tamper with the areas that you want to disinfect. However, we must keep in mind that UVC is a very highly energetic form of radiation, so it can harm some materials. The way UVC is used for disinfecting and killing microorganisms, there is two mechanisms. First of all, it is capable of breaking the DNA chains. So the UVC breaks the bonds between amino acids and leading into this non-functional DNA, so the microorganisms cannot replicate anymore. Another way how UVC is effective against the bacteria is by rupturing the cell walls. DNAs and RNA of most bacteria and viruses, they are most sensitive for the radiation wavelengths between 260 to 270 nanometers. However, germicidal effectiveness of UVC radiation go all the way to 310 nanometers. So in some cases, you can achieve a little bit of disinfection power by using UVB LEDs. However, the most effective way of disinfecting is to limit the radiation in this wavelength area between 260 and 270 nanometers. When you are designing your disinfecting luminaires or germicidal luminaires, there's a couple of things how they are differing from the normal luminaires used for the general lighting. First of all, and most important, you must design your luminaire for the worst case scenario. So the germicidal light output is always designed for the end of life of luminaire. That's the worst case situation where the UVC exposure is at its least. This is made this way in order to ensure that your germicidal effectiveness is always above the desired range. How do you measure the effectiveness? You measure it by this logarithmic reduction of those microorganisms. We talk about this so-called R log values, which basically means that how effective you are in either preventing those microorganisms to replicate or killing them at all. And it's a good idea to keep in mind that it's always not necessary to kill all the pathogens. It's enough if we can stop them replicating. This way, we can achieve the same germicidal effectiveness by using significantly lower UV exposures, which is good for the materials, it's reducing luminaire costs, etc. What about the dosages? As we remember, the dose was the power on the area multiplied with the time. So you need a certain dosage in order to achieve a certain reduction of the microorganisms. And that dosage is subject to the pathogens that you are trying to attack. Different germs, they need a different amount of UVC light. And we can find that information in the internet. Here you have a couple of links to give you some idea about the dosage needed. And since the dosage is a factor of time and the factor of energy, we can achieve the same dose in lower power, but in that case it will take more time. Or if we can focus the light over the area, then we can increase the radiation output, and that way we can reduce the time needed for exposure. So we are starting to get close to the violet. Before we jump there, let's talk a little bit about the materials. The materials we use have been tested for the use of UVC. For the lenses, such as this violet here, we are using our special silicone grade that has a very high transmission in UVC wavelengths. It's also suitable for the very complex optical lens designs, and it's very easy to achieve ingress protection. In some cases, you don't need very complex optical designs. You just want to focus the light into the application. Then you can use the reflectors. We have aluminum reflectors. Aluminum has very high reflectivity over all the UV wavelengths. It's also very UVC resistant material. And the reflectors we have, they suit especially well on the UVC LED clusters. And here you can see a summary of our optics that we have determined to be suitable for UV. Of course, we have a star of the show, violet. More about that a little bit later on. But we can also use, for example, Stella extra wide beam or Stella Fresnel, or we can use Zoria, like this one here, in case where we want to have a more overall light distribution. So let's look at the violet a little bit more in detail. Violet is a lens about 30 centimeters long. It has 12 optical elements, and under each of the optical elements you can utilize either single LED, or in case of the CSP type UVC LEDs, you can build clusters up to 4 LEDs under each lens. So that clustering option makes it very versatile. You can scale your luminaire LED amount. For the single lens you can have from 12 LEDs all the way up to 48. And this will give you a great scalability on the power output. The lens is made from the highly UVC resistant silicone. It's elastomeric lens, and it's held in place by this stainless steel frame. Both are the materials that are very capable of long-term UVC resistance. And this enables to create more advanced and more cost-efficient luminaires than can be achieved with the traditional quartz glass window. The beam angles of violet range from 20 degrees for the single LEDs up to 40 degrees when used with the clusters. So the beam angle is somewhat dependent on the LES size or UV emitting light source size. However, this also allows you to fine-tune the beam depending on your application requirements. Here is an example of violet. We are comparing the luminaires made using violet into a luminaire having just a quartz glass. The purpose of this comparison is to help you understand what are the benefits of optics in the UVC. Here on the left we have an area that we want to disinfect. We are using 9 luminaires and we have 4 optics per luminaire. And the beam angle of those optics is 20 degrees, so we are really focusing the light from the greater distance into this area where it's applied. On the right, we have more traditional UVC luminaire with the quartz glass windows on protecting the LEDs, not so much optical control. And you can already see from these pictures that on the left, where we are using violet, we have a lot higher intensity on the application area, and we have greatly reduced intensity on the walls. Here on the right, with the quartz glass window, the UVC intensity over the entire area is more or less the same. And if we look at the results, the minimum, which is, as we remember, we always design these applications for the minimum. What is the worst case scenario? So minimum with the violet is 4.8 watts per square meter intensity. On the right, using the LEDs alone with the quartz glass window, our minimum irradiance is 2.7 watts per square meter. So we have almost double the irradiance when used with the optics. That means that you can reduce the quantity of the LEDs to almost a half of what is needed with the quartz glass luminaire, or you can reduce the time that you are applying UVC while still maintaining the same dose. Another example, here we have comparison of violet with Wyckoff, in this case Sol Wyckoff LEDs, versus the Wyckoff LED alone. And even here you can see how we get twice the intensity over the same area. On the horizontal axle here we have X coordinate value, that means the distance from the center of the effective area. And on the vertical axis we have irradiance values, that is the amount of UVC falling into that area. And you can see in terms of uniformity, we are pretty much the same. In terms of intensity, we are twice the intensity of the quartz glass window. So that was a brief introduction about UVC. We touched base on a little bit of details. We covered the violet. In case you want to learn more, contact your LEDIL sales, and these guys are there to help you in this area. From my side, thank you.